Welcome to the Techne Connect Automotive Podcast, aimed at inspiring the next generation of EE-related talent to choose a career within our space, whilst also supporting the current EE talent pool in making key career decisions. In each episode, we interview industry leaders to discuss their unique career paths, advice for those starting out in the automotive industry, as well as important issues currently impacting the sector. My name is Ferris, and I'm responsible for connecting automotive businesses to the best EE-related talent. Today, we are joined by Stephen Lambert from McLaren Applied, who spearheads the business electrification product strategy and program management division. Stephen's career to date has been remarkable. He got into the EV tech space early on and has played a pivotal role in world-class projects for renowned businesses such as Lotus and McLaren Racing. He also spent several years working in the intense environment of Formula One, where he's developed one of the most effective battery systems to date. In this episode, we'll explore Stephen's exceptional career, valuable insights for growing a successful team, as well as the career advice he'd give to his younger self. Hi, Steve. First of all, welcome to the podcast. How are you?
I'm good, thank you. How are you?
Yeah, very good, thank you. Very good as always. Let's start with some introductions, if it's okay, Steve. Do you want to give us an introduction of yourself?
Yeah, so hi, I'm Steve Lambert. I am Head of Electrification at McLaren Applied. What that means is I look after our electrification product strategy and also our program management. So any electrification products we develop, I make sure we're developing the right thing and we can get them to our customers on time.
Brilliant. And before we go into your career, which is an interesting one, who's Steve outside of work and what do you enjoy doing in your spare time?
Yeah, well, I'm first and foremost, I'm a father. I've got two great children, so that's a lot of what my time is spent on. And any other time I have, I've got an old Victorian house I'm renovating at the moment, so I don't do as much engineering as I'd like to in work. So I try and knock walls down and get my hands dirty where I can.
Brilliant. And we'll jump into your career. So you had an interesting start. You started with computer science, wasn't it? And then you pivoted.
Yeah, it was. When I was a teenager, I wanted to be a computer programmer. I thought that was quite cool. And then I got to university and started studying it. And by that point, actually, I started driving, and actually realised I quite liked cars and quite liked mechanical engineering. So I pivoted my degree somewhat. It's half with engineering, half with computer science to do a bit more electrical and mechanical engineering.
No problem. Where did you study?
That was at the University of Warwick, where I did both my undergraduate masters and my doctorate as well.
No problem. And you took part in Formula Student?
I did, yeah. I did Formula Student in my third and fourth year at university, and then actually my PhD was linked to what was then called Formula Hybrid, but I think has been pulled into Formula Student since, which was all around building sort of electric Formula Student cars.
Brilliant. And then after your studies, how did things grow from there?
Yeah, well, I started in my doctorate. I started working with, I should say, Westfield Sports Cars. So I built a hybrid Westfield. That was great fun. I managed to drive up the hill at Goodwood, which was a great experience. And then I went on to work for Lotus, building demonstrator vehicles, hybrid electric demonstrator vehicles, which was great fun.
Brilliant. And after Lotus.
After Lotus, I was engineering manager at a battery company, and then started working in battery systems engineering for McLaren Formula One. So we were developing the battery system for our engine partner at the time, and basically we're told to go and build the best battery you could do that was possible at the time. And it was a great time to be working in Formula One.
Absolutely. And obviously, F1 to a lot of people, pinnacle of engineering. How was your experience? Did you love the F1 or?
I really enjoyed working in Formula One. People talk about Formula One being stressful, and it is. But I think what's great is that they realise their stress, and actually that it's all set up to manage that, and you can just focus on your little bit of what you're doing. So in some ways, it was the least stressful job I've ever had. It was busy, but it wasn't stressful because they look after you and they want to get the best out of you. I guess my only claim to fame really in Formula One is the fact that I was part of the least successful McLaren team in history. So my bragging rights aren't great, but what I will say is the battery system we developed was one of the best on the grid.
Well, yeah, we can definitely go with that secondary factor.
Yeah.
You then finished with McLaren. Was it then you set up? Was it Veon?
Yeah, well, it didn't set up Veon, but I went in and I was managing director of Veon Energy Storage, which was one part of what was then Veon Group. Veon had bought up a number of smaller companies as the industry was kind of coalescing around electrification. Veon bought up a number of smaller companies, and I was looking after the energy storage part of that, which was all around batteries. That lasted a couple of years, and then I moved to McLaren Applied, where I started as head of electrification there, looking at setting up the electrification strategy in automotive.
Brilliant, fantastic. You've had all through your career, you've got into EV tech quite early, and then you've covered a lot of the angles, haven't you, of the EV tech spectrum now?
Yeah, I think I've been very lucky when I started doing my PhD, as it was then. Hybrid electric vehicles weren't really a thing. I think there was the Toyota Prius was about, and there was talk of us coming into Formula One, but it was really the early days of electrification. So I was quite lucky to get into it when I did, really.
Absolutely. And then we look back in your career now. What's been your flagship moments? What are you most proud of now when reflecting?
I would say some of the stuff I did at Lotus. We were really ahead of the pack when it came to developing hybrid electric vehicles. We did the Rolls-Royce 102EX, which was a really amazing concept car. Obviously, working in Formula One was great. I've worked on some great projects in my time. Some I can't talk about. One project I worked on broke the record at the Nürburgring for an electric vehicle.
Very interesting.
I've had the honour of working on some really, really exciting and fun projects. So there's not necessarily one thing, but a lot of individual projects.
Oh, absolutely. And then, based on your career experience now, one of the favourite parts of the podcast, if you could now go back to Steve at 16 years old, what would you tell yourself on reflection?
First off, don't do software engineering because you're not going to enjoy it.
Yeah.
That'd be the first thing. No, I mean, I did enjoy software engineering, but I liked cars a bit more, I think.
Yeah.
I think I've really enjoyed my career. I think I've been really lucky in the opportunities I've had, but I think there's been an element of luck in it. When I came out of university, I was a little bit aimless. I was living in a pub, running the pub and driving lorries at the same time. Didn't really have much of a plan until my supervisor gave me a call and said, or my old supervisor gave me a call and said, "You want to come and do a PhD?" And really, if it wasn't for that, I wouldn't have gone down the road that I did do. Whereas I look at the people I was at university with who were very proactive in finding internships or years in industry, and they really were able to develop their career a lot faster than I was able to. And so I think that's the one thing I would do is make sure you be proactive at a younger age, get that experience behind yourself, and generate those opportunities for yourself.
No, really good. And obviously, with engineers coming through now, what further advice would you give them regarding studying?
Yeah, so when we look at automotive engineering, still the most popular degree for students is mechanical engineering, and that's great, but the automotive industry is changing, and so I think certainly trying to have a look at or focus on electronic engineering or power electronics is really, really important. Even if you're doing pure mechanical engineering, understanding how what you're designing is going to work in the sphere of high voltage, or in the when you have electronic components, what the heat generation is going to be of those components, how that impacts what you're designing is really, really important. And that's probably one of the big changes in the automotive industry is how we're designing for electronics and electrical systems.
Absolutely, and that I think with the way engineering departments have been structured historically, it's been very much mechanical, hasn't it? Then you've got electronics, then you've got software. Now the synergy between the three, it's like the silos breaking, isn't it?
Exactly. I mean, part of my role to some extent when I was working in Formula One was helping the mechanical engineers there understand how they have to design and take into account for batteries for high voltage, creepage and clearance. What happens when you have 1,000 volts touching some components? How do we design for that? And that's just becoming commonplace now in the automotive industry of today.
Yeah, absolutely. It's a really key take. I think if you're going to study, even if you do the others, if you study mechanical, if you study electronics, try and understand all 3-4 disciplines ultimately.
Absolutely.
Wherever possible. No, great. You've had experience yourself, Steve, of growing departments, running your own company. How important has it been growing a diverse workforce that's contributed to success?
Yeah, I think diversity is massively important. I personally like to encourage a environment of being able to challenge. If somebody has an idea, whether it be a senior manager or a graduate, they feel they can challenge the ideas that are going on, so that we can get the most robust solution to whatever problem it is we're looking at. And ultimately, if everybody comes from the same background, they look at these things in the same way. So having cultural diversity, gender diversity, any form of diversity is a good thing. And when we're working in engineering, it is a problem that we do have a lack of diversity, and it is difficult finding a diverse workforce. And you've got to go out there and really, really encourage and look for and encourage people to apply for the jobs. Particularly women. At McLaren Applied, we don't do too bad at cultural diversity, but we do have gender diversity, but we could be better. And so this is something we're actively trying to address. But there is the problem that there aren't that many women working in the industry, or aren't coming through university in the industry at the moment, and that is an issue.
No, absolutely. And as part of your remit at McLaren Applied, I think you've identified yourself and as an overall company the importance of integrating people into the team before they've even started, and it's bringing that culture together really early doors.
Absolutely, it's really important that when we do bring people in as well, there's hiring people is essentially a marketplace. So if you've got somebody coming in, you want to make sure they want to stay with you. That's a good thing to do from a business point of view, but it's a good thing to do anyway from a person to person point of view. So when we make a hire, typically we'll ask people to come in and get to know the team, let them see the sort of things they'll be working on, understand how the company works. So when they then do start working, they can come in and hit the ground running, and they'll feel more comfortable. There won't be any big surprises. But also, hopefully help with retention, help making sure those people will want to stay working for McLaren Applied, and hopefully then find other people who want to and be an ambassador for us for McLaren Applied.
Absolutely, it's a good strategy. So if we look at the automotive industry now over the next 5-10 years, people are going to come into this space. What would you recommend engineers to focus on from a technical perspective?
So I personally think one area where there's a big gap, and it's going to be really, really important, is power electronics. So I guess the issue is it's not easy. I often joke that I got into batteries originally because the maths was easy. It's V equals IR and P equals IV is kind of the most complicated it gets at a high level. And power electronics isn't. Power electronics, you do need to understand things in a bit more detail. But it's really where a lot of the value, a lot of the complexity, a lot of the difficulties, challenges, and therefore the opportunities are in the automotive industry today. The type of power electronics you use, could start to be the same as it could start to be synonymous with whether you had a turbo or a GT car back in the day. So understanding power electronics and making sure that that's a real area for focus in the automotive industry. And I think there's a lot of gaps and a lot of opportunities for people coming into the automotive industry.
Yes, I totally agree with you. I totally agree. And if we look at the industry as a wider piece, what do you think's up and coming? Is there anything that you feel is going to impact the sector over these next few years?
Yeah, so we're working a lot with silicon carbide. So it's a switching technology. Most power electronics use silicon. Automotive and moving towards silicon carbide. We at McLaren Applied have had over 10 years experience working with silicon carbide in Formula 1 and Formula E. And so we're really taking that into automotive because we're seeing a big step change. We're seeing a lot of movement towards wanting to drive a lot of efficiency into vehicles and into drivetrains, and that's really what we've been doing in Formula 1 and Formula E. For both those motorsport series are competitions around efficiency, particularly when it comes to the drivetrain. And Formula 1 cars now 50-60% efficient, which is incredible. And Formula E, you get a set amount of energy and a set amount of power. The only way you get technical benefit is by being more efficient than your opponent. So that's really, really important. And we call that the third wave of electrification. The first wave was Elon Musk, essentially the early adopters, bringing out electric vehicles. The second wave is really the sort of start of mass adoption where we are now. So every OEM has an EV, or you can go into any dealership and they'll be selling you EVs. We're starting to see mass adoption and acceptance. But really what we're now starting to see is competition between those OEMs, and that's all going to be around efficiency. If you have a more efficient drivetrain, you can have a smaller battery. If you have a smaller battery, your vehicle will be lighter, your car will cost less, you can charge faster for a given distance. If it's lighter, then you need less energy again, so you can because the vehicle's lighter. So actually you can make the battery a little bit smaller again. You need less cooling system. You start to make yourself a better vehicle. And then we actually think the fourth wave is going to be all around driver experience. So, EVs are great in that they go from 0 to 60 really, really quickly. It's really interesting that they've sort of taken the question of performance away from where it used to be. You can go and buy a car for 35 grand now as an EV that will out-accelerate what a Lamborghini might have done 10 years ago.
It's frightening, isn't it, really?
Which is crazy to some extent. But they don't necessarily do anything else in a performance. That what performance is in an EV context hasn't really been answered. And so we think, following efficiency, it's all going to be around driver experience. How do you engineer character into a car? How do you make the drivetrain more engaging? All of these sorts of things are going to start to be really important as well.
Absolutely, especially if you're looking to appease the petrol heads in the industry.
Exactly. And I don't think fake noise is going to be the answer. It's all going to be around making an engaging drivetrain. And that's going to be around efficiency to make the car better, but that driver experience, whether it's fine motor control or a highly responsive drivetrain, there are things you can do with EV drivetrains that you just can't do with a petrol engine car. And we're just starting to understand those.
The factor that you've mentioned about we're in like a competition phase, couldn't agree more. It's like the way I tend to break it down is any inverter type business, whether it's a tier one or they're doing it in-house as an OEM, any business that's trying to make the next efficient electric motor, it's literally the race to make the best system because obviously the opportunity ahead is huge.
Absolutely, and there's so much learning to happen. There's a great example is there was a test done by Autocar a few months ago where they tested 11 electric vehicles. Top of the list was the Porsche Taycan, absolutely amazing car. Handles really well. It's a really well designed electric vehicle. Second of the list was the BMW i40, again, really good car, fun to drive. And this was a list of what the most fun to drive cars were. Third was the Kia EV6. And then, so you're now in a position where you've got a Kia being compared favourably to a BMW and a Porsche. That wouldn't have happened 5 years ago. That just wouldn't have happened. And so it's a really interesting time and shows what can be achieved by really understanding electric vehicle technology. Kia Hyundai have done a really good job of designing around efficiency. And that's one of the reasons why that car is so fun to drive.
What's your perspective on the uptake of hydrogen and hydrogen fuel cell technology?
I think hydrogen will have its place, but not in automotive. There will be edge cases where it makes sense, potentially in off-highway, agriculture, construction, possibly long-distance haulage. But I think batteries are proving now that even today's battery technology, have answered the case for passenger vehicles and are starting to answer the question around commercial vehicles as well. So I think hydrogen will have its place, but it's not going to be a mainstay fuel of the future for mass transit.
We've seen, in order for EVs to be the complete normality, we need to see the transition in the supply chain as well. Obviously, I've seen a few things in the industry. I won't name companies in particular, but companies have struggled. They've done all the really good pre-development work. They've got all concepts out, and then actually when they've tried to go into mass production, it's fell down because of the supply chain. What's the challenges here, Steve, from your perspective, and what needs to be done ideally?
So, there's two things that have happened at the same time, which has kind of been unfortunate. Obviously, we had the pandemic, and what that meant was essentially the automotive industry was shut down. Nobody was buying cars. The demand was turned off by the OEMs, and as such, all the silicon manufacturers turned their attentions to other things they could make, such as laptops, because everybody was buying laptops because they're working from home. The problem is when you do a change like that in something like the silicon industry, it's got a 2, 3, 4 year cycle time, and so what we found then was what happened at the same time as the pandemic was really the electric revolution happened in mobility, and everyone started buying electric vehicles, partly driven by seeing less smog about, but partly just because the technology became mature at the same time. And so what we're starting to see is huge amounts more silicon in electric vehicles, coupled with a lack of supply of silicon. These two things have kind of created this perfect storm, and the industry still, it's getting better, but there are still long lead times for a lot of vehicles at the moment. And we're also seeing, I mentioned earlier, silicon carbide, which relies on very similar types of supply chains. We think we're going to see a big demand in silicon carbide as we go into this competition phase. Big demand's going to come on silicon carbide, and at the moment the fabs aren't quite there to supply that demand. There's a lot of investment going in, billions and billions of investment is going in by companies, but it's more needs to be done. There's a lot of talk about building battery factories, gigafactories, but really we need the same sort of focus on building fabs, which is where devices are made, building these fabs for silicon carbide, to make sure that we have enough supply of these components.
Yeah, absolutely. And we've talked about the electric motors, and obviously for a lot of these motors you need rare earth sources, don't you? And how do we reduce that?
One of the things I think, to be fair, the automotive industry does well is really gets down deep into the supply chain. So when you look at the battery supply chain, there's been a lot of talk on the impact of battery materials, and actually because of that focus, the battery industry has really managed to make sure that their supply chain is clean. The mines are clean. They're not they're not using the sort of labour that they shouldn't be. There's been a big focus on that. There are other supply chains that could do with an equal amount of focus. And an interesting one is the rare earth magnet supply chain. So a lot of motors are made with rare earth magnets, but at the moment, the supply chain isn't as clean as it could be. There's a lot of environmental fallout from some of the mines they're made in. And a lot of OEMs are pushing towards using non-rare earth magnet machines. But again, what this means is you're probably going to go to something called an ESM motor, so an externally excited synchronous motor, which actually means you're going to want more power electronics in your vehicle. So what you start doing is you start driving a current in your rotor, in the motor, instead of using a magnet, which means you want more power electronics. So yes, there's going to be some cleanup of the supply chain, but also there's going to be technical answers to that as well.
It's really interesting. And we talked about the efficiency through the drivetrain and the relevant components. The other area, isn't it, is looking at the charging infrastructure and how you don't want to be waiting. Let's go back to consumer. You don't want to be waiting an hour, or when you can fill your car up in 2 minutes using petrol. So what do you think is coming from a charging perspective?
Yeah, so we think the industry is going to move to 800 volts. Most of the cars you buy today are 400 volts. But that limits your charge capability to 150 kilowatts, something like that, 200 kilowatts perhaps. If you go to 800 volts, it basically means you can push twice as much power down the cable into the car as you could at 400 volts. And that allows for sort of charge currents of about 350 kilowatts. And that's one of the reasons why both the Taycan and the sort of high-end IKEA offerings are able to charge in 20 minutes or something like that. It's a real game changer for how you buy and how you use your electric vehicles. You're going to stop, as well. I think it's also going to help make electric vehicles more affordable by them having smaller batteries. So if you have a smaller battery, but you can charge it in 10, 15, 20 minutes, well, actually then you can start using it much more like you would do with an IC engine vehicle. Most journeys are less than 10, 20, 30 miles, so you don't really need to charge that often, and charging at home or on the street is probably suitable for a lot of people. But it's only when you do want to do those longer journeys that you'll then start fast charging. And so for the few times a year you do that, you can do that and it's not an impact.
Yeah, so I think you've given us a really good flavour of what the current challenges are and what's coming up. And I think if we can go through that transition as a whole industry over the next 5-10 years, we'll see the outcome.
Yeah, absolutely.
We'll see the outcome. And the $1 million question, if you like, but from your perspective and your perspective only, Steve, why develop a career within the automotive industry?
Firstly, cars are cool.
Yeah.
But I think, there are some very unique challenges. You know, you get to work on something quite cool, but in a very structured and detailed way. You know, when I look at my career, I've worked a lot of fun cars. I've driven cars up the hill at Goodwood. I've worked in Formula One. You know, some really interesting projects, but all with a really, really top of the industry focus in terms of, you know, be working for the best companies, you know, with the best people, with the best technology, you know, really being at the forefront of technology, and that working on interesting projects with the best people and the best technologies is incredibly rewarding.
Yeah, no, absolutely. Steve, it's been an absolute pleasure. Thank you very much for joining us, and thank you very much for the insights.
No, thank you, Ferris. It's been my pleasure.